Hi, this is MC Chetty for a new episode of my Forge modding tutorials for 1.20.1. It has been a while, I was a bit busy and it took a while to prepare this tutorial. Basically, we're going to continue from the previous tutorial where we made the power generator as well as this block, which uses power. Problem was you have to connect them because we have no cable system. So let's level this out a bit, it's easier. We're going to make a cable system. Let me show you how it will work. Like that. It's as simple as that. And if you have multiple, then you can make connections like that. So that's one thing that we want to support. We also want to be able to mimic blocks. We are now mimicking sand. Now we have cables that are hidden. And if you break them, you get it back. The final feature we want, also mimicking, should also work on glass. Let's try that. Yeah, that actually looks nice. Okay, it should also be possible to put the cables in water, so they are waterlogged, which you can see here. So that's also something we want to support. So how are we going to do this? In our existing tutorial, we're first going to make, let's close this. Okay. In the blocks, those were the previous blocks. We have a new cables module. How do you structure your mod is up to you. I chose to do it here so that everything for cables is nicely separated. So we have these blocks. By the way, I would also like to clarify that this tutorial is already on the wiki, episode 5. So you can find the text-based tutorial right here. So let's start with a cable block. It's a simple block like usual. One thing that's special is that it extends simple waterlogged block, which is an interface where a few things are, but you actually don't have to implement anything of this. It's optional, but just implementing this is one of the steps for being waterlogged. The other step is here get fluid state, where we query our waterlogged property. Yeah, that's the third step. We need to add the waterlogged property to our block properties. Okay, but let's first continue with the rest. So a cable has 6 normal properties, which indicate what the type of connection is at that direction. For example, here, so that's east, so the east side is a connector, and the west side is just cable, and the other 4 sides are non-empty. So if you look at connector type, it has non, cable, or block. Those are the 3 values, and we use an inner property, so each of these properties for our block state can have one of these 3 values. This is new. We also have a model property, and that's used for the facade. These properties which you attach to the block state have to be finite. It has to be a fixed number because all block state, all permutations of these properties are generated in advance. And yeah, this is 3 to the power of 6 different block states that we will get. But you can't do that with this because you don't know how many blocks there are going to be. There are tons and tons of block states. So this has to be a model property, and we will see later how that model property gets rendered, how we get to the render. Because it's also really look, if you look closely, you can see the outline for the cable. So it's accurate. Here we target the send behind it, and here we target the cable. To do that, we have all this. So these are the shapes of the cable itself. So that was west side, so the cable on the west side is this part of the bounding box. And if there's a block at the west side, then it will be this shape that's added to it. And the logic for that is done here. I will go with that in a moment. The constructor is pretty basic. We call the shapes here, and we set the water log to false. The other properties, these other 6 are calculated when we set it down. That's new block entity, and the ticker, we've seen that in previous tutorials, that's the same. Now, for shapes, the basic method you have to override for the shape is this one. But it has to be very fast because it's called a lot. So that's why we have this cache here. But let's zoom in a bit so it's a bit easier to read. So first we get the different connector types on all 6 sides. That's done by checking if there's a block there. If it's a cable block, we say cable, otherwise we say, if it can be connected, we say block, and otherwise we say none. And then for these 6 values, we calculate the shape index, which is basically every time, so we have the length of this will be 3, and every enum value we multiply with 3, we add another, multiply with 3, and so on. So we basically, these 6 values, we combine them in one big integer, which is an index. And that index will be the index of the shape cache. So that's basically how it works. And in make shapes, we go over all possible 6 directions. We calculate the same index, and we make the shape for that connection. And we do that by starting with this box, which is the center. If you put, it's just that's this box, and then we combine it. If the connector type is cable, we add the cable shape. If it's block, we add the cable shape and the block shape, because in this example on the east side we need both the block shape and the cable shape. So that's basically how this works. Yeah. What we also need to do is, whenever, for example, if I place a cable here, this block also has to be updated. See, it updates because of neighboring change. And that's done by calling, this here we change the cable network. I will explain that later. But in this routine, we actually also calculate the new block state. This is called when our block itself is placed. And this is called when there's an update for an adjacent block. So if you do this, then update shape will be called for that one, which allows us to recalculate our state. You also need to do this. That's to make sure that water flows correctly. That you that you do this here. Yeah, I put a comment there because I don't know what the last parameter means. Okay. Yeah, when the block is placed, you also do this. That's just to calculate the block state. And here you also do mark 30. Calculate state, gets the connector types on all 6 sides, and it computes the block states needed at that point. That's for water logging. That's, yeah, we did that later. And is connectable checks if there's a block to connect. For example, if I would put send here, there would be no connection because send doesn't support energy. Okay. The block entity for the cable is similar. It's just a block entity like we had in previous tutorials. It supports energy. Remember that forge energy is a push system. So in order for this generator to get power over here, it actually just has to push its power into this cable. And this cable will then do the rest of transferring to there. Yeah, let's also see the others actually don't have power because that power is sent straight to these blocks without going through this. That's for efficiency reasons. Yeah, so we have an energy handler as usual. Here we cache the outputs. So that means for every of these cable sections, cable blocks, we have a cache of all the outputs, these 2 blocks that are supported. That's calculated when we needed it, and the mark 30, that's called right here, will clean that cache so that it has to be recalculated, because as soon as you, for example, set this there, it has to recalculate the outputs. Okay. Yeah, so every time here we do the processing, every time there's energy in our block, in our cable, we check all the outputs. So this will calculate all the outputs. If it's not empty, we distribute energy to all handlers that can receive energy. This isn't perfect. This is not a perfect algorithm. There are many better ways to do this, but it's simple. So I basically divide the energy that we have with the outputs, and I then distribute it over all outputs. But if there happens to be only one output that can receive power, then it will still only get the amount divided by the number of outputs, because it doesn't keep that in mind. That's just a limitation. You can try to fix that if you want. This function actually updates the cache of outputs. So if it's 0, if it's null, I mean, it will traverse all cables. I will explain this routine later, but what it basically does is it will traverse every cable on the network, in this case 1, 2, 3, 4 blocks, and for each of those you get the position, you get the cable, I mean the cable block entity. This function is called, so this is a consumer, it's called for every cable that is in the network. And for every cable we go look in all 6 directions and see if we can find something that supports forge energy and if it can receive. In this case, that's only these 2. Mark 30 also uses traverse, and it set all outputs to null for the entire network. And traverse is a recursive function which basically for each cable, checks all 6 directions. If it's another cable, it will go there. It will not go back because it keeps where it's already been in this set. And we add the initial position there first. And we also accept the consumer there. And then we do the rest. So these two work together. It's just recursion. Okay. And the rest of the block entity is basic saving and loading. Nothing special. We also need a facade. A facade is essentially, it extends CableBlock, and Facade Block entity will extend CableBlock entity. The reason for that is that in this, for example, this traverse logic, we can do instance of CableBlock entity, and the facades are also considered for that. So it extends CableBlock. It also has getShape. GetShape in this case will check if we are mimicking something, and it will use the shape of what we are mimicking. So for example, here you see the shape is actually the shape of the block. By the way, I forgot to tell that, but mimic is pretty nice. Let's mimic grass. Oh, I need to right click with this. Yeah, okay, was using the wrong button. Mimicking. Yeah, the color is a bit weird, but it works. Speaking of color, also need to explain that. If you mimic, I always click the wrong button. If you mimic with grass, it will have the correct color for the biome. It's also something we handle. Okay, so when the facade block is harvested, we need to pop resource, which is a method that will from block Java, which will pop the item into the world. So that takes care, if you're in survival, to return the grass, the facade. You also do undestroyed by player, and that's to actually calculate, put back the cable itself, because although it looks like it, these aren't two blocks. You can't have two blocks on the same space. It's just the facade block that's now rendering both the cable and what it's mimicking. It's just one block. So when you break it, you actually remove the facade block and put the cable block back. And here we calculate how that cable block should look like. When you have a facade in your hand like this, it's a block item. But for facades, we actually need a custom block item, because we need to handle the mimicking, which you can't do with the normal block item. So we have facade block item, which, for example, overrides hover text, which makes sure that you get this tooltip. Okay, and it has a few useful helper functions to get the mimic block, to set mimic block, user set mimic block, which also gives a message to the user, to the player. And this is the important one. This function is called when our block item is right-clicked on something. So when you right-click with the facade, use on is called, and then we check what we are targeting. We are hitting a cable block, so we want to replace it with a facade block. So we calculate state for a facade block, and we call place block, which is vanilla. And yeah, we also use this context. This is a small class that we made. It's to be able to call place block, you need a block context, and that block context can be the standard vanilla block context, but we need to replace when you place the facade, you need to replace what's already there. That's why replace clicked has to be true. Okay. Here we do place block. If that's successful, we get the sound. We play it, and we set the mimic block from our item stack. And also handle the growing, the shrinking actually of our what is it called? Item stack. Yeah. If we are hitting a facade block, we copy what it's mimicking. For example, if I right click this, we are now mimicking grass, and I can put that here. But if I prefer glass, I can do it like that. Otherwise, we want to set the mimic block. So that's the case when you do this, for example, or this. Okay, that's for the block item. The block entity extends cable block entity. This we have to make sure that when something changes on the server side, we have to make sure it also updated on the client side. And that's done with this, which sends an update on the client, and this one, which is related to this model property. This will make sure that our model is actually updated, and the baked model, which we'll explain later, is also recalculated. Yeah, so then you have the two important get update tag and get update packet and get update tag. Get update tag is called on initial load of the chunk, and there it's called server side, and we make a compound tag where we save our mimic information in, and that will be sent to the client, which will load. So that means that if you on the server set the mimic block, then the client will get notified and it will be able to call request model data update. That's when the chunk is loaded, and this is called whenever, for example, when I do this, then that's the point at which this is called. It does actually do the same thing as this, basically. It also saves the mimic in a compound tag, but it does send the packet directly. Okay. This is also for the model data property system. It's called by this on the client, on the server, I mean, to get model data which will be sent to the client. Why this is done this way, I will explain in a moment when I get to the block, the cable, the block model. The rest is just basic stuff, nothing special. Alright, so these are all the basic classes. We of course have to register them. So we have this and this. Make sure to use facade block item for the item here and not just block item. And we also add them to the creative tab. Now we want to render this, the shape of that cable, and that's done with a baked model. And a baked model is static, so that means that it's only recalculated when needed. So when I do this, then this block there will have its model recalculated. Okay, and that's done with a baked model. First you have the baked model loader. It's a geometry loader. It has a certain ID so that you can use it in JSON, and it's registered, which is registered, by the way, in client setup through the register geometry loaders event. Okay. We want our baked model to be used. So both normal cables as facade blocks use the same baked model, but we need to distinguish it. So that's why we have a loader that supports one property facade. To make this clearer, let's see how our model is generated. So the cable, it has cube as a parent. It's not a facade and uses this model loader. And the facade is exactly the same except that it sets facade to true. So this is the JSON that will get loaded by this geometry loaders. And yeah, we remember the facade property here, and then we simply bake the model. We make a CableBakedModel. CableBakedModel is what is actually responsible for rendering the shape of that cable depending on the neighbors, and also rendering the facade. Like that. Very important, in the bake method, getQuads method, which is used to actually calculate all the different pieces of the geometry of this model, you don't get a level or you don't get a position. So you can't get the block entity. You're also not allowed to do that because this happens in another thread. So you cannot get information from the facade block entity, for example. You need to get it either from the block states for the 6 directions or from model data, which is given here in this parameter. This is the model data that was previously calculated by facade block entity. This will be this model data, and it will contain the model property facade ID. So that's our block state can access data from our block entity. Okay, this is a bit more complicated. Basically, there are 4 different, let's see. For every 6 directions, it can be either need a cable or not. So for example here, this one has 3 directions for which there is something, either a block connector or just a cable, and the other 3 directions are empty. And there are only 4 parameters here because this is always looking from a specific direction. This is actually has to do, if you want to render this one, it ignores these 2 cardinal directions and only looks at the 4 around it. And that's represented here. It's a bit complicated, and I'm not sure how to explain it exactly, but basically it's for each of these, for example, false, 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 that represents this one would be like that. On all 4 other directions, there is nothing, not a block, not a cable. So it would use this. So that means it doesn't have anything. Sprite none represents no texture. There's nothing there, and there's no rotation either. But in this case, one of the directions, I'm not sure which one it is, but we can look that up. Hold on. So that's north. We could look at the north code. For north, west, east, up, and down. West, up, east, and down are the 4 patterns. So let's say there's a cable here. So we have an L shape. That means east is true because we are looking at the north. So east is true. the third parameter. So that means we will use this one, false, false, true, false. And then we have to render this sprite end. That sprite end. Yeah, sprite end with this rotation, and that rotation represents the east rotation. It was a lot of work to make this table, but yeah, that's how it works. We have, yeah, remember I said earlier that textures are baked into a big atlas texture. In the previous tutorial I mentioned that. So here we get those textures, and let's show them. So that's for the connector. And here you see, and that's actually what we are rendering here in this, with that pattern stuff, this small section. That's what that is for. So that is always correct. Like that. That was what all that section was for. This section, I mean. Okay. Yeah, this is the important function. It does all the work. First, we make sure we have the textures if they are not already there. And then we need to get quads. There's a case if we have a block state, that means that we are rendering our block model in the world. But for rendering in the inventory, like here, your state will be 0. So then we will be in this case. And this is where we need the facade boolean, which we get from the model loader. Because in that case, if we are facade, we just render like this, a simple block. And otherwise, we render a cable with everything set to none. Okay. And we also here we return because we don't want to render anything else. And then comes complicated systems. Yeah, these are pattern parameters. If you want thicker cables, you can change that. And here we go over all 6 directions. And for each direction we have 3 possibilities. If up, this would be up is cable. So there's a cable above us. And in that case, we need to render this section. This will be handled separately. If we have a block on top of us, we also have to render this part. And otherwise, if we have nothing, we need that pattern system that we explained earlier. That's for this side to render this little thing. Only this thing is handled by this, and it uses that pattern system. We do this for each of the 6 directions. Yeah, so these functions are helper functions. They are defined in the baked model helper, which is just an easier way to make these quads. Finally, we render what we are mimicking. So we get the extra data, and if that's set, we get the model for that block state, and we get the quads for that. I always do catch exception around it, because you are basically rendering something from another mod, possibly, and there's always a possibility there's a bug there. And I know from experience in XNet, if your mod crashes, but it's caused by another mod, it's you that gets the bug report. Ideally, you should log this here, but yeah, I didn't bother in this case. Yeah, so this is a complicated code, but it's only called whenever something changes. So now this will be called, and now as well. So that's why it's pretty efficient. A few standard things here you have to override. We want to render on all render typesets. The reason for that is that we want to render for transparency as well as just normal solid. So that's why that is. That's the break particle. And we return transforms from the context so that our item looks correct and uses the same model. Okay. Yeah, that's basically this. This thing, it makes sure that when we are mimicking something, we get the colors from what we are mimicking. That makes sure did the wrong thing again. Okay, no, I need to right click, not middle click. Always clicking the wrong thing. Okay, so this is this color. I don't know. Swamp, for example. Okay, it put me. So here you see the grass has a different color. Let's see. Yeah, it's correctly mimicking the grass of that biome. I wonder, can we mimic a mushroom? Just testing. Nice. So that works too. Yeah, so it's pretty flexible, the mimicking thing. Okay, so that's what this does, and you also have to register that in client setup, register call handlers event. So one final thing I want to explain is data generation. I will not go over everything because it's basically just the same as usual. There's one special thing though. You also want to render, as you could see, we want to render this. Generate, I mean. We want to generate that. And to do that, so these we had before, we added these two. We add this class, CableLoader Builder, which is a custom loader builder, and it knows how to add the properties that are custom to our loader, and that's only the facade property. And here you can use it. You get the builder for cable block. The parent is a cube. By the way, using this parent, make sure that our item has the correct transformations. That's why this is important, so that the items looks correct in the inventory. And use a custom loader like this. So that's all there is to it. So as I said, the wiki is completely updated. I hope you enjoyed this tutorial, and yeah, see you in the future for a new tutorial. See you later. Bye bye.